Although this video will focus on the transmission of Shiga toxin-producing E. coli, we will first take a look at some background information about E. coli as a whole. E. coli is a rod-shaped, gram-negative bacterium that is commonly found in the intestinal tract of animals. Although E. coli is a singular species of bacteria, there are many different variations, or pathotypes, of the bacteria. These pathotypes can be further subdivided into serotypes, making for a high degree of diversity amongst E. coli. While many commensal forms of E. coli can reside within the human body without ever causing harm, there are some pathotypes of the bacteria that can cause serious illness. One of these pathotypes, known as Shiga toxin-producing E. coli, or STEC for short, generates a harmful toxin that can permanently damage the nervous system and kidneys of infected individuals. In the case of one especially nasty serotype of STEC, E. coli 0157H7, symptoms include severe abdominal cramps, bloody diarrhea, and vomiting. While these symptoms often appear within 24 to 48 hours of ingesting contaminated food, they can appear as long as 10 days after consumption.
For a healthy adult, most of these symptoms subside within 7 days, but for young children and the elderly, these acute symptoms can give way to chronic health problems. From kidney failure to death, the potential implications of the disease make it one that should not be written off as insignificant. In the video to come, we will examine the means by which STEC can be transmitted throughout and persist within the environment. But before we begin, there are two key terms that you should know as they pertain to the disease transmission: a vehicle and a reservoir. A vehicle is an inanimate object on which the disease-causing agent can exist until it is transmitted to its next host. A reservoir, on the other hand, is an environment or organism in which the agent not only exists but thrives. The agent often multiplies exponentially within the reservoir without ever causing harm to the reservoir itself. In this way, it can be hard to visually screen for the presence of the infectious agent until it is too late. Now let's see how these terms come into play in the context of Shiga toxin-producing E. coli.
The primary means by which STEC is transferred is the fecal-oral route, meaning feces from an infected organism is ingested by a healthy individual. Before we go any further, we should clarify that this is often not a direct transmission. Unless you eat a healthy serving of poop soup on a daily basis, you are much more likely to obtain STEC from a middleman, aka a disease vehicle. While it is possible for STEC to be transmitted from person to person by, say, a contaminated door handle, many cases of STEC involve direct transmission from ruminant feces to human mouth. Now let's take a look at an example.
Because E. coli exists naturally within the environment, it's not too uncommon for ruminants such as cattle to become infected. In our case, let's say a cow ingests a harmful strain of STEC. Even though the bacterial agent produces the Shiga toxin within the ruminant, the cow lacks receptors for the toxin, a factor that allows the cow to grow to maturity without experiencing adverse health effects. Thus, for the time being, the cow serves as a reservoir for the disease. During slaughter, suppose some of the feces from the cow's intestines makes it onto the meat, contaminating it with STEC. In this instance, the piece of meat has now become a vehicle for the disease. The meat is packaged, shipped, bought, and prepared, and it's at this point in the preparation, that things get a little tricky. If, and only if, the meat is cooked thoroughly and does not touch other items before cooking, will the E. coli transmission be effectively stopped. However, a more likely outcome is that the uncooked meat will come into contact with surfaces and utensils, thereby cross-contaminating them with the bacteria. Thus, if a cook were to taste test the food using a contaminated utensil, there is still a high likelihood of infection, even if the meat was cooked properly. This is especially true for highly infectious serotypes like STEC, because as little as 10 bacterial cells can result in infection. When these faults in food preparation happen in isolation, the suffering, although intense, remains limited to a small number of individuals. However, in this increasingly connected world, the potential impact of foodborne illnesses such as E. coli can reach devastating levels, and this supposed potential has been made a reality more than a few times in recent history. In the infamous 1992 to 1993 Jack-in-the-Box outbreak, 732 individuals became infected with E. coli 0157H7. The source of the bacterium was traced back to a rather sizable batch of improperly cooked hamburger meat. While most of the victims managed a stable recovery, the outbreak resulted in the death of 4 children and left another 178 individuals, both adults and children alike, with permanent health issues such as kidney and brain complications.
Up until this point, we have exclusively mentioned transmission of STEC via meat, but it's important to note that there are other ways that the disease agent gets around. Feces can make it into or on other food products, such as vegetables or raw milk, and if these products aren't treated properly, the risk of infection remains high. For instance, in 2011, an E. coli outbreak that affected over 4,000 individuals was linked to sprouts grown at a German farm. The agent involved was a novel strain of STEC called O104H4, which caused a high frequency of hemolytic uremic syndrome. Most of the affected individuals lived in Germany or France, but the outbreak did leave its mark in small pockets around the globe, affecting populations in the US as well as Canada. In all, the total death toll of the outbreak came to 53, a number that is much higher than most meat-based outbreaks. Possible reason behind this apparent anomaly is that sprouts, in comparison to meat products, are less likely to be cooked at bacteria-killing temperatures. As such, the likelihood of infection goes up.
E. coli can even be transmitted through the water we drink. This is why boil water advisories are often issued during a major storm that results in widespread flooding. The massive amount of rainfall can cause the sewer lines to back up into household pipes, thereby contaminating the water supply with E. coli and many other disease-causing agents. Interestingly enough, however, one of the worst water-linked outbreaks of STEC was not due to massive flooding, but rather human negligence.
On March 17, 2001, in the small town of Walkerton, Ontario, 7 children at a local school were reported to have severe stomach cramps. 1 day later, a sampling of the town's water tested positive for STEC, but this alarming fact was not passed on to health officials for almost another week. Rather than choosing to believe a water supply could serve as a reservoir for the disease, the water facility management urged investigators to look at more common reservoirs, such as beef, for the cause of the growing number of cases. By the time the outbreak had been attributed to contaminated water, over 2,000 of the town's 5,000 residents had been infected with STEC.
As you have seen, there is no shortage of ways by which E. coli can be transmitted to human hosts. It is this high degree of transmission versatility that makes it one of the most persistent foodborne pathogens out there. With that said, there are 2 simple tests that, when done right, can greatly reduce the impact of the bacterial agent. The first is as straightforward as it gets, preparing your food properly. On top of cooking food thoroughly, one should always make a conscious effort to limit the cross-contamination of surfaces and utensils. This prevents the most common type of transmission for STEC, that is, from ruminant feces to human mouths. The second task is to make sure you wash your hands regularly. While person-to-person transmission of STEC is minor in comparison to food transmission, keeping your hands clean can help limit the potential of accidentally transferring STEC from a contaminated surface to your mouth. By following these 2 simple guidelines, you will soon become the face that E. coli sees in its nightmares.
Having said that, there are still some remaining challenges that we face when trying to decrease STEC's presence in the food supply. One of these challenges is preventing the spread of E. coli that contaminates fresh produce, which can occur when fruits and vegetables come in direct contact with contaminated animal feces or irrigation water. E. coli is difficult to remove from fresh produce because the agent can grow in small crevices on the leaves and are not able to be removed by merely rinsing the food item. An example of this is the romaine lettuce E. coli outbreak in November of 2018, which was announced 2 days before Thanksgiving. The outbreak infected 62 people in 16 states, as well as 29 Canadians. Moreover, the cause was traced back to a strain of O157H7 found on a Santa Barbara County, California farm in December. One way to decrease risk of infection from fresh produce is to purchase your produce from reputable grocery stores. Furthermore, it is always a good practice to keep fresh produce away from meat products to avoid cross-contamination.